Hi, welcome to the next problem. So I managed to reproduce the graph in this particular case. So as per the problem, if we have to, this was 1.0 and this is 1, 2, 3, 4, 5, this is 2.0. So just to make the point visible there, and this is 10 seconds and this is 20 seconds. So this is the time axis as per the problem, and this is the displacement axis. Of course, this is the origin which we have here, and time they measure it in seconds, and displacement in this case is in meters. So as per the first part of the problem, the ask in the problem is to calculate the average velocity in this case. So V average, as we had discussed in the previous problems, is a total distance traveled by total time taken. So in this case, in this particular case, the only way we can identify the total distance is to calculate the highest point till the distance has moved. After this point, the distance has remained constant, displacement has remained constant in this case. So from the graph we find out this value is 2 meters. So which would be converting 2 meters by the total time taken. So from this graph it is like the time till which the distance has kept on changing. So which we find is 10 seconds here and this 20 seconds. After this point there has been no increase or change in the distance even in this particular case. So that would be 20 seconds. So converting meters to centimeters, we have 200 cm by 20. So knocking off the zeros, we have 10 cm per second. Okay, this completes the first part here. The second part we have been asked in this particular problem is to find the maximum velocity in this case. So as per the graph, if we were to look at it, to find this, since we are doing calculations using the units per graph, we see that each unit on the graph is equal to 2 seconds in terms of time and 2 seconds and 2 meters in 20 centimeters in terms of distance. Okay, so taking that into consideration and observing the graph, we find that the body has been accelerating. How do we know it's accelerating? Just try to find the slope. The slope kept on increasing till this particular point in time, and then it stayed constant, which shows that the body has moved with uniform velocity for a certain time, and after this point it has started falling. So if you see the slope of the graph, it's actually moving towards the right, which shows that the slope is actually reducing in this particular case. So for this particular case, if you see, there's a period for which the body has traveled with uniform velocity, prior to which it has been increasing, stayed uniform, and then kept on falling. So this velocity where it had stayed constant is a place where the body had maximum velocity in this particular case. So if I were to calculate the velocity here, so this is the time and this is the distance. So how many units of distance? 1, 2, 3, 4, 5. 5 into 20 cm, which we have discussed earlier. So velocity max in this case is equal to distance or displacement by time taken, which is equal to 5 into 20, as we said, is 100 centimeters. So how do we calculate the time? Same way, seeing the number of units of time that have passed before the body has actually started decelerating in this particular case. So you see, this will be 2 units and 2 units, which is 4 units. So that's equal to 25 centimeter per second. This is the maximum velocity the body has reached in this particular case. Coming back to the third part of the problem, we have been asked to find out that instance in time where the instantaneous velocity of the body is equal to the average velocity of the body at that particular time t. So how do we find the average velocity? Here as we calculate the total distance by total time. So what about the instantaneous velocity? Instantaneous velocity is nothing but the slope of the graph at that particular instant in time. So if I have to consider the slope of the graph at here, so this particular point has an instantaneous velocity. If I consider the slope of the graph here, this is the instantaneous velocity at this particular point in time. But whereas average velocity is actually calculated by the slope of the graph which actually passes through the origin. So this particular problem cannot be solved mathematically, it can only be solved geometrically. So if you have a slide ruler, you can just point it from the origin and then start experimenting in this manner, like, okay, here the slope is very less. Okay, so in this particular case, the instantaneous velocity cannot be equal to the average velocity. You can do it mathematically. Okay, so in this particular, it's kept on increasing. Sorry, I'll just repeat that action. So sorry again, that's yeah, now I got it. So at this particular point in time, if you see, the slope of the graph is nothing but the instantaneous velocity at this point, as well as this would be the average velocity. For any other case, it would be very tough to find out. Here the slope is almost towards the origin, and since it cannot be calculated mathematically, so since it's increasing, it will never fall in place. So the another way of looking, another scenario which we have is the other end of the graph, which always passes as secant but doesn't form as a tangent. So the first line which we have drawn in this case, which is this one, line 1, would be the likely solution for this particular problem. So if you look at the time point at which this is actually a tangent to the graph, it would be this is the one. So 1, 2, 3, 4, 5, 6, 7, 8, which is technically 8 into 2 seconds is equal to 16 seconds. So at this point in time, we have an average velocity, which is the total displacement of the total time, and where we have the instantaneous velocity at this point at 16 seconds, where the instantaneous velocity will be equal to the average velocity for this particular problem.